Alright, welcome to our first lesson on algebra. Our first lesson on algebra, where we will be dealing with quadratic expressions, an introduction to quadratic expression. Now, a quadratic expression is written in the form ax squared plus bx plus c. Ax squared plus bx plus c, where a, b, and c, a, b, and c are real numbers. And in any quadratic expression, a cannot be equal to 0. So let's go that over again. A quadratic expression is written in the form ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. It's okay if b and c can be 0, but if a is equal to 0, we will no longer have a quadratic expression. Now, what a, b, and c represents, a represents the coefficient of the value of x squared, the coefficient value of x squared, the coefficient value of x squared. So if I have an example of as 3x squared plus 5x minus 8, x is the value in front of the x squared. X or a will be equal to 3. A will be equal to 3. So in this case, in this quadratic expression, a is equal to 3. Now, b represents the coefficient of x. B represents the coefficient of x. So what is the coefficient of x here? Here, x. We have 5x, so the coefficient of x is 5. So b is equal to 5. Now, c is our constant. C is a constant. There is no variable with it. It is a constant. X is a variable. X would be the variables, but here there is no variable. So this is known as a constant. And in this case, the constant c is equal to negative 8. So when we write in a quadratic expression, one of the things I will encourage is write it in this form, with the x squared first, then the x, then our c value. So a would represent the coefficient of x squared, b represents the coefficient of x, and c is our constant. Now let's talk a little bit more about a and c, the a and the c value, what this tells us. Now the a and the c value, let's start with the a value. The a will tell us the shape of our quadratic curve. Now, any quadratic expression will give you a curve. Will give you a curve in this form. Let's say it's like that. It gives you a curve. Now, a tells us what type of curve it will be. If a is positive, our curve will be this shape. Right? It will give us, let's say, a smile. Right? You know that smiley emoji? If a is positive, it will give us that smile. Now, if a is negative, it will be this way. It will be upside down. It will give us a frown. Right? So if a is positive, it gives us that smile. That's the shape of the curve. If a is negative, it gives us a frown. It's upside down. Now, another thing we need to talk about is c. C is known as the y-intercept. C is equal to the y-intercept. Now, when something intercepts another, it's the point where it cuts, or the point where the two places meet. Here it is, what is the y-axis? The y-intercept is where the curve cuts the y-axis. So this is our x-axis. This is our y-axis. The c represents this value here, right at that point where it cuts the y-axis. So therefore, let's go back to this expression. In this expression, since a is positive, it will give us a shape like this. It will give us a smile, and since c is negative, it will cut our y-axis at -8. And that brings us to the end of our first lesson, to have you understand what quadratic expressions are all about. They are written in the form ax squared plus bx plus c, where a, b, and c are real numbers, that a is not equal to 0. If a is positive, it gives us a smile. If a is negative, it gives us a frown. And the c represents where the curve cuts the y-axis, And that brings us to the end of our first lesson. In our next lesson, we will see how we form quadratic expressions by multiplying binomials.